Assalamualaikum and hi, my name is BAKHTIAR. I will present for our introduction for our project which is auto water sprinkler. Okay. For our product, it is automatic irrigation involving a gadget or timer system for controlling the irrigation. This project enables changing water flow even when the irrigator is not present. The key component for our project is efficient water distribution for plant health and water saving. Our project focused on automatic water sprinkler system using fluid mechanic concepts such as Bernoulli principle, pipe uses, and fluid power. Our project goal is to optimize water distribution, reduce every consumption, and improve user convenience.
A water sprinkler works by spraying water in a circular pattern over a designated area. The sprinkler is connected to a water source, typically a hose, and has a mechanism that rotates the sprinkler head to distribute water evenly across the area, to making sure that each plant receives enough water to ensure that the finished product is in a good shape, which need a lot of effort when watering plants, but it can cause overwatering and waste of water. In order to help with the situation, a new invention called a timer was created. The timer is a device that allows to measure a specific amount of time conveniently. It typically consists of an electronic circuit that counts time, controls, and output, such as an alarm or visual display, to indicate when the desired time interval has elapsed. The timer primarily goal was to assist the farmer in providing enough water for each plant according to its requirement. The timer was installed at the tap that connect to the direct pipeline, and it can be switched on and off as needed to water the plant and after that process is complete. So, here the flow on how this product works.
For methodology part, we have organized the information into a flowchart. In the water sprinkler, the water supply is pushed into the pipes, resulting to a backflow. The preventer is placed near the source of water, where the preventer will prevent polluted water from entering the system and compromising water supply. The valves govern how much water flows via the system by opening and closing. Then, water runs through the pipes and out of the sprinkler heads when the valves are open. The pattern of discharged water from the sprinkler will depend on the head of the sprinkler. Some heads revolve to evenly disperse water from a big area. Others oscillate or spray in a certain direction. When the timer runs out, the valves will close and the system turns off.
Assalamualaikum everyone. Today I will present about this video from Hera production. We explain about the water used for sprinkler irrigation. Initially, water will be taken from the spring using a water pump and it will flow to a pipeline connection to the sprinkler irrigation. Irrigation is distributed over an area of 10 meters and the water will come out of nozzle and then sprinkler from the irrigation system at angle of 25 degrees.
Hi, my name is Yojazi and I'm the group leader of Group 5. So now I'm going to present the discussion and the concept part of this project report. So the first principle that contained in this auto water sprinkler is the Bernoulli's principle. Bernoulli's equation relates between pressure, velocity, and elevation. In other words, it's the relation between the pressure, kinetic energy, and gravitational potential energy of a fluid. Bernoulli's equation is used to understand the pressure distribution and the range of water being sprayed by the auto water sprinkler. The formula that contained in this Bernoulli's equation is P plus 1 over 2 rho V squared plus rho GH equals to constant. And as we know, the diameter of auto water sprinkler is quite narrow. So according to the Bernoulli's principle, the decrease in diameter of pipe causes the increase in velocity of fluid, and it brings with the decreased internal pressure in the pipe. So water flows through a narrow pipe will create a high velocity spray, means it accelerates when it exits the nozzles, and hence The plants at a longer distance also can be watered by the auto water sprinkler as well. The another fluid mechanics concept in the automatic water sprinkler is losses in pipe. The automatic water sprinkler is consistently associated with the pipe. Consequently, another connection between fluid mechanics and the auto water sprinkler lies in the understanding of pipe losses. Friction losses and minor losses are two types of pipe losses. Friction loss is a form of energy caused by interaction between flowing liquid and the material that is flowing through. Usually is the inner surface of the pipe. The most common formula used in calculating friction losses is the Darcy-Weisbach equation, which H equal to F times L over D times V squared over 2G, or P equal to F times L over D times rho V squared over 2. Minor losses refer to the decrease in energy or pressure caused by a localized disruption within a conduit, such as variation in cross-sectional area, protruding gasket, bends, valves, and comparable components found in an automatic water sprinkler system. An efficient automatic water sprinkler system can significantly reduce energy and water wastage over and calculating the combined impact of friction losses across the pipe network and minor losses occurring at sprinkler heads, fittings, valves, and other components. By optimizing these factors, the total pressure loss of the system can be minimized, leading to improved the performances and resource conservation of the automatic water sprinkler. And for reminder, the formula for the minor losses is H equal to K times V squared over 2G, or P equal to K times rho V squared over 2. The third and the most important concept in the automatic water sprinkler is the fluid power. Fluid power is the use of pressurized fluid to generate, control, or transmit power in an automatic water sprinkler. Fluid power is mainly divided into two, which are hydraulics and pneumatics. A concept based on pneumatics can also be utilized in a portable timer system designed for an automatic water sprinkler. Pneumatic actuators are employed to regulate the opening and closing of control valves in the automatic water sprinkler. By connecting a pneumatic actuator, like a pneumatic cylinder, to the valve mechanism and activating it with the compressed air, the valve can be opened or closed according to the predetermined schedule programmed into a portable timer system. The formula that involved in the pneumatic power is P equal to Q times P, where pneumatic power equal to rate of compressed air times pressure difference across the pneumatic components. Furthermore, the another fluid power is hydraulics. Hydraulic power can be utilized in multiple ways within an automatic water sprinkler system, including powering the water pump and managing the movement of sprinkler head. The formula that involved in the hydraulics power is P equal to Q times P, where hydraulic power equal to flow rate times pressure difference across the hydraulic component. Hydraulic power drives the water pump in an automatic water sprinkler system, which draws water from a source and supplies it to the sprinkler system. It efficiently powers the pump and provides necessary force to move water through the system. Additionally, hydraulic power is utilized to control the motion of the water sprinkler head. Hydraulic actuators adjust the position of the head, ensuring that every area of the garden is watered and maintaining the flexibility in the irrigation system. Lastly, the fluid power and water sprinkler system involve the concept of flow rate, which is the amount of fluid moving per unit time. This applies to the water sprinkler system as well. Flow rate can be categorized into three types, which is volume flow rate Q, mass flow rate M, and the weight flow rate G, where the formula of volume flow rate is Q equal to LV, the formula for mass flow rate is M equal to rho Q, and the formula for weight flow rate is G equal to gamma Q.
In conclusion, sprinkler water irrigation use the Bernoulli principle to achieve the maximum water uses. From that, we can know loss in pipe sprinkler irrigation water, such as friction losses, leaking losses, and evaporation losses. So the system requires the monitoring, training, and maintenance to adapt technology environments. In the end, we can say the sprinkler irrigation system successfully through schedule flexibility to improve automation and valve performance will be sustained to agriculture practical. Overall, it shows the sprinkler irrigation system is potential to be effective efficient water management methods. Thank you for watching.